Potentially making progress. Maybe not making progress.
It's your screen on here on Zoom.
Oh, you can?
Look at tab.
Oh, there we go. Okay. Thank you. Hope that's why. Okay, thank you guys for your patience. Sorry about that. Sorry. One last thing. Maybe you can see my presenter view if I do it like this. Oh, you can. Okay, so I'll get rid of the presenter view. Okay. All right. Hello, everybody. My name is Hannah, and I'm going to be working with Jeff and Stan today to do a brief intro, a not so brief intro to SwiftUI. Okay, so as always, here's a link to the slides in the Discord, as well as the link to the slides completed demo and running demo, if you'd like to follow along. And then I'll give a second so you guys can get that. Okay. Is everybody good? Have them if they want them? Okay, awesome. All right, so this is our second to last session. We're going to be doing intro to SwiftUI. Okay, so starting off with what is SwiftUI? All right, first off, I have a question for everybody. Does anybody know what wins hackathons? This is subjective, so any answer will do. And your answer for prize. Yes. Yeah, front end wins hackathons. Very good. Yes, so front end is, I can't say that it will win you hackathon, but it definitely is very important because looks are very important. And this is a hint for maybe how you want to frame your project for Hoth 12. So quick shameless plug. If you have not signed up for Hoth 12 yet, please do so now. Hoth stands for Hack on the Hill. It is a 12-hour beginner-friendly hackathon that's going to be happening this Sunday, March 2nd, in the Grand Horizon Ballroom in Covell Commons. Here's the application link. We can also have it out on our Discord everywhere. Would definitely recommend coming. I hope to see all of you there. It's a lot of fun. We'll have a lot of good food. You'll learn a lot. And yes, applications close Wednesday, so try and get it done before then. Are there any questions about Hoth before I move on to the actual workshop? Is everybody signed up for Hoth? Did everybody apply? Yay! Okay, awesome. Alrighty. Okay, back to the workshop. So back to sort of some motivation for why front end and UI is so important. I have this screenshot of the UCLA Ideologic webpage, which if you don't know is a website that's used for club sport membership stuff for UCLA. And I have a few things that I think are not fantastic about this webpage, but does anything stand out for you about what's not so great about this website? Yeah, go ahead.
It looks old.
Yes, it does look old. Anybody else have anything that they aren't a fan of? Yeah. It is weird. It has a weird layout. Awesome. Those are both very good observations, and I completely agree. Another thing of mine that I think is bad with this website is it has links that don't work. Obviously, you can't see it in the screenshot, but it's very confusing, takes you in roundabout ways, very hard to use, not intuitive. Also, there's some confusing symbols and coloring. Why is there a big red X there when the background is green? I'm confused. Do I have something I need to do? Am I approved? I have no idea. So very confusing. And then also weird image layering. This goes back to what you pointed out. What was your name?
Me?
Yes.
Kevin.
Kevin. Well, Kevin pointed out it's old. It's not very stylistically fantastic. So yeah. So I don't want to use this website. And I'm sure you guys have all had very similar experiences with other websites that are old. I know there's like the stereotypical like old government site that have never been updated. You don't want to use something that doesn't look good. So same goes for application. We want people to be able to understand our application and like looking at it when they first open it up, so they're more likely to stay. And that is what SwiftUI is going to help us do. So SwiftUI is a declarative framework that enables us to create beautiful and dynamic user interfaces for Swift projects. If you haven't heard of it before, declarative just means that when we're writing the code for our user interface, we're going to be describing what we want the UI to look like, and SwiftUI is going to handle the implementation details and the how. This is kind of best understood in contrast to an imperative UI syntax. And if we had something like this, we'd be writing the implementation details and logic, and stuff like that. More nitty-gritty details, if that makes sense. And just as a quick example of the difference between declarative and imperative framework, so let's say that we have an application that we want to show some content, but only if a user is logged into the page. So they'll go to our fancy purple login button, hit login, and see this wonderful picture of Oprah, who's really excited that you came to this workshop. So thanks for being here. So there are two different ways that we can implement this. There's the imperative way, in which we would specify all of the nitty-gritty logic that we would need to show this. So we'd start off by finding the image in our document and then calling a member function, telling it to display on the screen, but only if the user's logged in, and if they're not logged in, making sure that it's hidden. The declarative way of doing this in pseudocode is much cleaner. It's one line. It's just saying that the image is visible if the user is logged in. So I don't know about you guys, but I definitely prefer the second option, and SwiftUI is gonna kind of do this for us because it's gonna make it really easy to write our UI code, and it's gonna make it easier to read and thus easier to maintain. So yeah, so that's the big picture, some motivation about why we're gonna use SwiftUI, and then Jeff is gonna jump into some more of the actual implementation that we're gonna use for our app.
Right. So let's get into views. What's a view? A view is not a picture of mountains. Well, it could be. Okay, so a view in SwiftUI is a building block of your app that allows it to display what you want to actually have on your app. And there are two main types of views that we'll be going over: text views and image views. So can someone tell me what the text view on this image or this app is? Should be an easy answer. Yeah?
Hello on that.
Exactly. So this would be the text view. And what would be the image view? Anyone? Sebastian?
The asshole.
Exactly. So that's the image view, right? So a text view basically just displays a line of text to the screen. Here we have the syntax, so it'll just be text, hi, I'm in Apple, and it'll display, hi, I'm in Apple. Image views. So image views are slightly more complicated. You get images from a folder in your like text editor, from a folder with the extension of .xc assets. Basically, you would just put any image. It could be in any image format like PNG, JPEG. Just put it into that folder, and then Swift will take care of that for you. And if you want to display on your screen, you just take that from the assets library and put it on your screen. So here we have two images of apples. And how do you organize these different types of views? We have three organizational techniques: VStack, HStack, and ZStack. In a VStack, basically the views are just stacked vertically. In an HStack, the views are stacked horizontally. And ZStack, the views are overlaid on top of each other. All right. So VStacks, what they do basically, they just align the views vertically down the screen. So here's the syntax. It's just VStack and your views, view 1, view 2, view 3. And here we can see some text views that are aligned vertically down the screen. So HStacks are basically the same thing. They align views horizontally across the screen. We have HStack, view 1, view 2, view 3, and they align some text horizontally on the screen. ZStacks, what they do basically they just stack views on top of each other and create overlapping images. So this syntax is basically the exact same, but here now the images are stacked on top of each other. All right. So spacers, what do spacers do? Basically, they just make things farther apart. For a VStack, we can space them out. So we have two apples close together, and if we add a spacer, they get farther apart. If we have a HStack, we have two apples close together, they get farther apart. So spacer, parentheses are basically, it's basically just a syntax. All right. So we can also have buttons, and what the buttons do, you click on them and they perform an action and they do something. So here we have the syntax, we have button, parentheses, action, colon, and then write whatever action you want your button to do. And then you can also have the button have an image and some text. So in the picture we have here, the text would be click round and yeah. So how do you make these views look nice? You make them look nice using a view modifier. Basically, under the view, you would have changes to these views using modifiers. We have modifier 1, modifier 2, modifier 3. Basically, let's say we have a boring old hello. We can change it using a view modifier, sorry, to make it look nice. All right. So let's get into some text view modifiers. We have dot bold, dot italic, dot foreground color. Basically, what that does, it changes the color of the text. And we have dot background. Basically, it changes the highlight of the text. So here we have the syntax. Text hello will just create a normal text called hello. If you bold it, it'll bold it. If you make it italic, it'll make the text italicized. And if you have a foreground color, it'll change the color of the text. If you have a background color, then it'll change the highlight of the text. So we have some image view modifiers here. Basically, if you do dot resizable under image view, it'll create a resizable image so you can change it later if you want to. We have dot scale to fit. Basically, it resizes the image to the screen width. We have dot scale to fill, which changes the image to the screen height. We have dot frame, which changes the height and width of the view. Corner radius changes or rounds the corners in case you wanted something more circular, I guess. And you have shadow, basically that creates a shadow, dot border, and that outlines the images. All right, so we also have a view modifier called dot overlay. What this does, it stacks a view on top of another view. It's similar to ZStack, but keeps the original view layout, while ZStack arranges views in a specific order on top of each other. So for example, if we started with the original view of a circle and we wanted to overlay this image over here called Swift, basically it'll keep the original frame and just overlay Swift on top of that. There are different like different overlays we can have, like ellipse, rectangle, and a capsule. This looks like a pill over here. All right. So we can also have button view modifiers. We can reuse the text view modifiers to change the view of the button, and we can have image view modifiers that changes the image of what the button looks like. Here we have the syntax of a button. So we have button action like before, and then now we can add some text to it. So if you click on hello, it'll click on the button, and we can change the font, the foreground color, and the background of hello. We also have an image high. So let's say I imported the image and we named that high. You can change the corner radius, the shadow, and the border. All right, so let's get into safe area. So what is a safe area? Basically, it's a default of your app and your views won't cover the safe area, basically. If we have like the time and important widgets, like this corner over here, and we don't want the view to cover it, then by default, it won't cover it. And only if you do dot ignore safe area will the view cover that area over here. All right. So now let's get into a little demo. So, okay. Yeah, actually, Sneha will go over the demo.
You can just keep the recording from the computer.
Okay, cool. So now using what we've learned about SwiftUI and views and modifiers, let's go back to our app, Rune Eats, and see how we can implement some of these things on our front end. So currently, the past few weeks, we've been working a lot on the back end, implementing our database systems, authentication, and other things. But right now, our front end still looks like this. It's a little sad, but what we want is to be able to have users to see the login registration page, and then once they log in, be able to access all of the things we've been working on in the back end, such as the restaurants, reviews, and be able to interact with it. So breaking down the views and what we need to have when the user logs in, we have first our restaurant list view, which is going to have all of our different restaurants together. And can anyone tell me what kind of view this is? We just learned about them. VStack. Yes, that's correct. So it's a VStack of a lot of our smaller views, which are our restaurant row views combined. So basically what you can do is in order to make reusable components, you can nest a few views inside of each other, which is what is done here with our smaller components being nested into our larger list view. And right now for our demo, I'm going to take us through building this smaller restaurant row view. So taking a look at this specific row for B Cafe, we can see that this entire thing is structured into first a larger H stack with the image on the left-hand side and all of the information and texts and review data on the right-hand side. And then this is further divided into another stack. This is a V stack here where we have our title and then our description and then our ratings below it, which is then again further nested into another view where we have an H stack inside of it with our star for our little rating symbol and then the actual rating next to it. So as you can see, views are kind of an easy way to be able to divide up and containerize a lot of the different things that we have going on in our app and make them reusable so that we have a similar format for all of the different components that we want to have. Okay. Yeah, rating. Okay. Okay, so now going back into our code. So for the past few weeks, we've been working in our backend folder, and we haven't really touched anything in the Bruin Eats app frontend folder. But I think in our second session, we went over building this folder. Right now, you shouldn't have anything in it except the main boilerplate, but today we're going to be working in this. If you've been mainly working on the backend folder and you don't have this, you can also go to the running demo that we have on the slides and then git clone and then use the backend from our last session on session 4, I think, and then pull the front end from session 2, which is just going to be this basic boilerplate. Okay, cool. So first what we're going to do is right now, okay, wait, let's first run this to see how our app's looking right now, actually. To load. Okay, yeah. So as we can see right now, it just says hello world. So the first thing that we're going to need to do when building our restaurant row view is we want to be able to, like we did in the previous sessions, we kind of defined a model structure for the different things that we need to have in a restaurant, which includes like the title, the description, the reviews, and things like that. But all of those are in the back end. And we don't really have anything related to that in the front end. So the first thing we want to do is define that same model in our front end. So we're going to go to our folder here and then create a folder called models. And then inside it, create a file called restaurant. where we're going to define the model for our restaurant. Okay, so first we're going to import foundation. And this is just a basic Swift library, which contains a lot of the necessary functions we're going to be using. And then we're going to define our model structure for our restaurant. So also, sorry, okay, is everyone following along at this point? Does everyone have their front end open and is able to, or does anyone need any help? Yes.
Trying to clone the rooms.
Okay. I think. Is everyone else doing okay? Wait, maybe we can pause for a second. Does everyone have their front end folder open? Can I have a thumbs up if you have the front end folder working? Yes.
On the week too.
So you can clone the entire running demo library, and then in it, there should be like different sessions in it. The back end is from week 4, and the front end should be from week 2. So just open those specific folders. Wait, but use the code that's in session 4 for the back end. Because that should have everything included up from what we covered from the last section. Can I have a thumbs up if you have like the simulator running and it shows hello world? Yes. Okay. 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 I'll wait for like 1 or 2 minutes for everyone to get set up and then continue. I think for the sake of time, I'll continue on. And then all of this, if you're not able to follow along directly while I'm coding, all of this code will also be uploaded to the running demo right after. Okay, but I'm just going to continue defining my model for the restaurant with all of the different variables that we defined in the backend. So codable, codable. Okay, so we're going to have our ID, which is of type UUID. Type the name of our restaurant. The description. Our image URL. Are created at date for the date that the review was posted on. Average rating. And our user. Okay. Did I spell codable wrong? Yes, there's no E. I'm gonna see, try and see what's creating my error real quick. Okay, sorry, user should be user. Okay, cool. So now that we have our restaurant model structure defined, we're gonna go and start actually coding our component, our view to show and display on our screen. So now I'm gonna go and create a new folder called screens. And inside screens, I'm gonna create a file called restaurant list view. Okay. And in restaurant list view, this is where I'm going to be using SwiftUI to create the component, and then later on creating our entire list of components to display on this page. So I'm going to start off by importing SwiftUI. Then I'm going to make a struct for my component, which is going to be looking like this. So I'm going to call it struct restaurant row view of type view. And then I'm going to define a variable called restaurant, which is basically saying that when you're calling this restaurant row view struct, the user has to pass in the restaurant for which they want this information to be displayed. Okay. And then I'm going to make our first view, which as we saw was an H stack between our image and our text description. So I'm going to make my view body. And I'm going to make my first H stack. And on the left-hand side, we have our image. So I'm going to have async image and then URL. For our project right now, we're using URLs from the internet. So you don't have to import any pictures into your directory. Instead, we'll just be using a URL straight from Google. So it's going to be of type URL and then string restaurant image URL. And because it's an optional field that we defined earlier, I'm going to put these question marks, which just represent that this field is optional. Okay. And then image in image dot resizable. And then now I'm going to start using the modifiers that we talked about to do some formatting with my image. So I'm going to do image dot resizable dot aspect ratio content mode fill. So this means that for whatever size that my phone screen is, I want the image to fill that entire size. And then frame, specifying the size of my image. And then flip shape, which is the shape that I want my image to be in. And I want it to be a kind of rounded square. So I'm going to use rounded rectangle with corner radius of 8. Where did I write frame? Frame. Okay. Cool. Okay. And then I'm just going to define in case, because this image is optional to upload. So in case it's not uploaded, we want to have a placeholder image. So I'm going to say placeholder, and then I'm just going to define a gray square to take the shape of it in case the image has not been defined. Okay, so now that we have our image, the next component that we have in our view is our text, and our text is also further split up into a vertical stack. So I'm gonna have after this a V stack expected. Okay, so I don't know why I keep on spelling frame like, okay, sorry, my bad. Expected. I'm missing. Okay. Okay, yeah. Back to defining our VStack. So I'm going to define our VStack for our text with alignment leading. And then add the text for our restaurant name. It's going to be a restaurant name, then restaurant description, and then after that, the rating review. So restaurant name, and then I'm going to use a modifier font to be of type headline, and then our restaurant description. And I want this to be a little bit smaller than the name, so I'm going to use font of subheadline. And then I want the text to be gray, so I'm going to use foreground style gray. Okay. And then again, in our VStack, we're going to have one more nested stack, the last one, which is going to be the H stack for our review here. So I'm going to define another H stack with an image for, and I'm going to be using the star kind of symbol that is just provided by us as a symbol by SwiftUI. So it's going to be star fill with color yellow, and then text for our for the number, which is going to be the review format. Be a colon. Okay. Where am I missing a comma? Mm. Wait, give me 1 second to see where I'm missing a comma or something. Yeah. Okay, sorry. I think I realized I misspelled something. I misspelled alignment and system name. But okay, once you fix that, you should have your restaurant row view looking like this. And then after this, we want to be able to display this on our screen. So we're gonna go to content view. This is the kind of main view that we have where in which we can call other views, but this is going to be the one shown up on preview, which is why this text hello world that's here right now is shown up here. And right now, even though we have our restaurant row view component made, we don't have anything hooked up to the backend yet, which we're going to do in our next part. So for now, I'm just going to define some kind of boilerplate dummy data for us to have to pass into our restaurant row view to show this. And I think for the sake of time, I'm just going to copy paste that part of it. And then if you want, you can see it. You can go and see it on the slides as well. But basically, in my view, I just changed it from hello world to then calling our restaurant row view and then passing in this restaurant object, which I've defined with the model that we created before, and just filled it in with some basic boilerplate data for us to be able to see. So if I stop running and then run it again. As we can see, our first row view component is showing up. Okay, so sorry for all the technical difficulties, but I'm gonna pass it back to Hannah to continue talking about state and environment variables. So then we can then talk about connecting our front end to our back end and displaying all of the different objects. Okay.
All right, nice. Sorry. Thank you for.
All right, so let's quickly go over arrays and lists. I think they'll be pretty similar to other languages if you learn them. So an array, basically what that is, it's a data structure that Swift provides us. So we can define an array like var, which is variable vowels like A, E, I, O, U. That would be an array of 5 elements. It holds data values of the same type, such as a string type. So we can say let fruits, apples, bananas, watermelon, and basically this initialize fruits with 3 elements, right? So what is a list then? This is different from an array. Basically, it's a SwiftUI element, which that instead of storing data, it'll store views so that later you can like actually display those views. Here we have list and we have 2 views, apples and bananas. And then as you can see on the right, once we display those views, it'll show up in a list. So we have apple, banana, and then I think Sneha will demo that later. So what is the difference between arrays and lists? Basically, you should use arrays when you want to store and manipulate data. So like sorting a list, basically, sorting an array, you would want to store that in an array to like more efficiently actually change those data. And it's actually more efficient than lists because you can, I think all of one time, if you know what that is, like you can directly access an element in an array and not you. It'll be less efficient if it was from a list, basically. And you should use lists when you want to display a collection of items to the screen. So basically a collection of views. Basically, if you want to display that, just put it in a list and then you should be able to display it. So that was a brief overview of arrays and lists, and Hannah will go over closures now.
Okay, this is kind of switching gears to something a little more like conceptual. It's actually talking about something that like we've already seen. You just may not know the name of. So this goes back to our button example that Jeff went over earlier. And I don't know about you guys, but I definitely have looked at the syntax and been like, what the heck's going on with all those curly braces? So let me just quickly change this back to a format that you may be more familiar with. So here's a more familiar version. We have our function say hello, and we have our button. And so the button syntax expects you to pass a function as a parameter. And then when you click on that button or press that button, it's going to execute the function that you pass, if that makes sense. This is a perfectly fine way to write this syntax, but SwiftUI actually enables us to do something a little more clean. It looks a little more clean when you write your code. So yeah, so that's something known as a closure. But before getting into that, quick note, if you want to write your syntax like this, like I said, that's more than okay. It might be more understandable for you as a programmer. Just make sure that when you pass your function as a parameter, you do not include parentheses at the end of it. Because that would actually cause you to call your function and then pass whatever that function returns as the parameter. In this case, since we don't have a return value from our say hello function, you'd be passing an empty parameter. So our button wouldn't actually do anything when you clicked on it. So yeah, so back to closures. We can make this even prettier by passing the function directly as a parameter. So that's where all those curly braces come in. As you can see, we just, instead of having the function definition, we just put the body right in here with the action parameter as expected. So yeah, so this is a closure. A closure is a self-contained block of code that can be passed around in your code like a variable. They're functions that you don't have to write out explicitly or give a name to. If you are familiar with some other programming languages, these are similar to anonymous functions or lambdas. You do not need to know what those are, but just if that helps with the understanding. So yeah, so in SwiftUI, the general closure syntax is shown below on the screen. As you can see, it's very similar to traditional function syntax, but there's a few key differences. Mainly, as you can see, there's no function name, so we don't have like an actual declaration. And then everything is contained within the curly braces. So we have the parameters and return type here. And then additionally, there's this special in keyword that's highlighted in red that separates the parameters and return type from the body of your function. There's also a few cool things that SwiftUI lets us do with closures to make it even simpler in certain scenarios. The first one is we can actually get rid of this whole front line. So the parameters, return type, and that special in keyword if our function has no parameters or return value. So like our previous example with the say hello function, since we had no parameters or return value from that function, you can actually get rid of that entire line. Also, if your closure is a single line function, and the value of that one line is what you want to return from it, you can leave out the return keyword. So that doesn't make a ton of sense. So let me just do a quick example of a more concrete difference between a function and closure would look like. So this is a function and a closure that both perform the same operation. They add two numbers together. In the function is just traditional function notation. You have your add numbers, add nums function name, the parameters return type, and this return keyword. And then down here's the closure version. As you can see, all the parameters are located within the curly braces. There's that special in keyword we talked about earlier, and then the return keyword can be omitted to make it cleaner. And You might know if you're wondering, when should you use a closure versus a function? So if you're expecting to use that block of code over and over again in your application, it is a good idea to use a function. This just makes it easier to reuse your code, and that way you don't have to copy and paste the same lines over and over again, which makes it cleaner. However, if you anticipate only using that block of code one time throughout your code, for example, when a specific button is pressed, then it could be a good idea to use a closure to just, yeah, simplify the syntax and yeah, make less writing, which is always good. Okay, were there any questions about that before I move on? I know I went kind of quickly. Okay, perfect. Okay, so this is kind of one of the bigger fish sections of content-wise of this workshop, and that's state bindings and environment variables. I'm actually going to skip over bindings again for the sake of time so we can get into the demo. So these concepts will make a little more sense. We don't actually need bindings for our application, just the different state methods that SwiftUI provides. But they're in the slides later if you would like to go learn about what a binding is. Okay, so as you guys all probably know, an important aspect of any application is being able to update a variable and have that change reflected in your app. So for example, in our Bruin Eats app, we want the rating specifically to be reflected in the user interface. So when anybody updates the rating of a restaurant, it's accurate for anybody else who's using the app. Another example, traditional example that you may think of is a likes feature for any sort of post on like a social media app like Instagram. And one way that we might think to implement this is in the code that's shown on the right. So we'd have a view, a likes variable declared up top, and a button that when you click it, increases the likes count. And kind of a leading question, but do you guys think this code will work? No, it will not work. It'll actually give you this funky error that's like most error messages and it's hard to understand. So it'll say left side of mutating operator isn't mutable, self is immutable. It throws this error because we have a view and in Swift, okay, sorry, let me back up a bit. So we have our view, and in this view, the likes variable is a property of this view. And this view is a struct, is a type struct, and in SwiftUI, structs are immutable objects. So that just means that when you have properties, I'm sorry, I'm like getting it turned around. So hopefully I'm not making this more confusing for you guys. In SwiftUI, properties of structs, like our likes variable, are immutable, which means that once you assign them a value, you can't then go back and change that value later on. So yeah, as you can imagine, this can create a headache, especially since being able to update variables is such an important part of any application. And one way we can get around this is using state variables. So state variables are a special type of variable in SwiftUI that are monitored by SwiftUI and are able to change their values inside of structures. Another really helpful thing that SwiftUI does for us is it will automatically update our view to reflect the most recent changes to the state variable. What's shown on the right is the syntax for how to declare a state variable. This state property wrapper is the key portion that you want to say to make sure that that variable is a state variable and can be updated inside of a view. And then this private keyword is a convention. It's not specifically necessary, but technically state variables are supposed to be private to the view that they're contained in, which you don't really need to know, but it's just good practice to keep that in your syntax when you're declaring a state variable. This is to try and make it a little more clear. I'm going to try and explain state variables in terms of a car analogy. So I'm sure all of you guys have at least ridden in a car, even if you've never driven a car. And you know that cars have a lot of internal data, like fuel level and your current speed that you're going, and stuff like that. So that would be considered the current state of your car. And while these are all really important pieces of data, they're not really useful to us as a driver or a passenger unless we have some sort of visual indicator about what's going on. And this is what our dashboard is for. So you have the speedometer and your fuel level and gauge, stuff like that. So the most important thing, however, about this dashboard is that the data is up to date and is reflecting currently what the state of our car is. So can you imagine if you're like trying to go on a long trip somewhere and your fuel level in your car says that you have a full tank, but you actually have like a quarter tank and then you get stuck with no service. That would be really bad. It would also be really bad if you were driving 60 miles an hour in like a 35 zone, but your speedometer said you were going 30 and then you ran into like a cop and got a ticket for going super fast. So anyways, those are extreme examples of a car that hopefully would never happen. But our state variables in our application are actually very similar to this concept. They require some sort of visual indicator to be useful to the user, which is why we put them in views. And B, they are only useful if they reflect, with the understanding that they reflect the most up-to-date changes in our application. So I hope that helped clarify things a little bit with state variables. But were there any questions about that? Okay, perfect. So some use cases of state variables. Like I mentioned before, state variables can be used to display a variable within a view. They can also be used to define different behavior in application. So for example, Boolean state variables would it's just set to true or false. It could be used to indicate whether like a certain feature of your app should be enabled or disabled. You can kind of think of like a game as an example. You could have an is running Boolean state variable, for example, that if it's set to true, then you have certain features that are enabled, and if it's not, then they're disabled. So that's another example of where you can use a state variable within SwiftUI. Okay, so do you think that's everything we have to do to manage state? Short answer, no. Unfortunately, state is very complicated, especially in SwiftUI. There are a lot of different kinds of state. However, SwiftUI gives us many ways that we can manage the state and store a state in our application. So we just covered state variables, which is defined with this state property wrapper right here. And I'm also going to briefly go over some other important property wrappers that will be useful for our demo. So there's the observable object, observed object, state object, and environment object. These are all have similar ideas backing them up, but there's a few key differences in how to use them. And I'll go over the concepts briefly right now, but hopefully they'll start to make more sense in the demo and in our actual code so you can see their exact use cases and how to use them. Okay, so starting with the observable object protocol, which was that first @observable object property wrapper that was shown. So this protocol enables the creation of objects that automatically notify their subscribers about any changes to specific pieces of data. This is similar to a state variable that you basically just like, when you have an object that has a property that will be updated, it's able to notify any views that depend on it when that update happens. So again, it's the most up-to-date piece of your app. So when you mark a class as conforming to this protocol, you're telling SwiftUI that the object's properties, when changed, should force a refresh of the views that depend on them. This is kind of technical wording, so I apologize if it doesn't make sense. And even though this is a possibility, we need some method to make sure that our views are notified of these changes when they happen. And we can do that with the @publish property wrapper, which will broadcast the changes to a property to its subscribers. And what I mean by subscribers here is just that any view that's watching that specific object to like see when its data changes. All right, so next up is the observed object. So an observed object is very similar to the state property wrapper in that it's used to observe and respond to any change to a specific property in an observable object. In this case, however, unlike the state variable, the external object is typically created and owned outside of the view hierarchy, whereas when you use the state property wrapper, that data is contained within the view itself, if that makes sense. It is most convenient and most important to use this if you have a situation where you have an object that is shared among multiple views. The state property wrapper by itself is not complex enough to handle those sort of nuances in your code. Okay, that was probably confusing. So any questions about that before going on? Again, hopefully it'll make a little bit more sense with the demo. But yeah. Okay, so moving on to state objects. State objects are also very similar. They're kind of an in-between of the state variables themselves and then the observed object property wrapper that's used. And it's used to create and manage an object, an observable object like before, but this time it's specifically within a certain view. In this case, the object is not external like it was for the observed object, but it is owned and managed by the view itself. SwiftUI does some great things, and it'll enable the view to automatically update when the state of this object changes. And this is used, or best to use, when the observable object that the view is watching, or the observable object that the view is watching is specific to that view or subviews contained within it. Okay, I'm gonna keep going, but please shout out if it's confusing, because I know that I was definitely confused when I was first making these slides. So yes, so just let me know. All right, okay, the last kind of variable state object method thing that I'm going to talk about is something called an environment object. And this is used to share an object, like before, the observable object, across multiple views in the view hierarchy. Like the observed object that I mentioned earlier, this observable object is created and owned externally, which is outside of the view hierarchy, but instead, unlike the observed object, it is placed within the environment, if that makes sense. Views can share or can access this shared object by using the environment object property wrapper. And it is used when the object needs to be shared among unrelated views without being explicitly passed down to the hierarchy itself. Okay, so that's a lot of technical information. Sneha's gonna jump back into the demo and okay, actually, sorry, before she jumps into the demo, here are some resources. They do a really good job of explaining the difference between these ways of managing state within SwiftUI. Would recommend if you're still confused. But yes, there's a lot of good information out there. And then, yeah, Sneha's gonna jump back into the demo, and then hopefully it'll make a little bit more sense about where these different kinds of ways to manage state will become useful within our application.
Okay, cool. So now let's go back into our app and see how we can make the one small view that we made and connect it to the rest of our app using all the things that we just learned about state and lists and arrays and everything. So quick recap, the model architecture that our app is following is model view controller. And kind of what we have right now, we have our model and controller separate, and we have our view separate, which is why in the previous demo, we just hard coded in the information that we were displaying on the screen. But that's not what we want to do. We want to be able to actually connect our view to the backend and pull our data from our database. So yeah, right now our view is made, but it's not connected to anything. It's sad. Yeah. Okay. And as we mentioned before, there are a lot of different things that we want to be able to do in our app to be able to communicate with our database. We want to be able to do all the CRUD operations like writing a review, showing restaurants, changing ratings, deleting reviews, and all these different things. So right now in the demo, I'm going to be taking us through the read operation, which is going to be pulling data from the database to show all the restaurants on campus. As we saw, they were listed out in the list when you log into the app. Okay. Oops. Okay, but to be able to do that, we need some way to communicate with our backend. And using that, just a quick recap, we're going to be using an API. So an API is basically a messenger or translator that allows for different software applications to talk to each other and exchange data, and provides a certain set of rules and protocols for how one piece of software can request information or perform actions on another system. So we're going to be basically using the API that we created on our backend in our past sessions yeah, so basically in our past sessions, we actually worked on creating our API, but now we're going to use it in our front end to be able to make those requests and communicate with it. Okay. So if you remember, okay, in our past demo, we were working on in the front end, but if you open up the back end and run it, you should get this server started on and the link that your server is running on. And again, for the backend, if you want to follow along, you can pull it from session 4 on the GitHub repo and just run it, and it should start. Yeah. Okay. So now that we have our API link, which is the one that our server has started on, we want to define it in our front end so we can actually communicate with it. So to do that, we're going to go, there's a lot of tabs open, sorry. Basically, once you run your backend, we're going to go back into the front end and we need some way to communicate with our link here. So we're going to make a new folder called constants. Oh, sorry, a folder called utils with a file in it called constants. Okay, and in constants, this is where we're going to be defining our base API URL. So again, we're going to import foundation. Then we're going to define our struct for constants. We're going to define our variable and make it a private static variable. And I'm just going to go to my backend and copy this link that my server is running on and put it here and then write -API. Okay. So this is basically going to be our base URL path, which points to our backend server. And then in it, we want to, if you guys remember in our backend, we defined a few different routes for like our restaurants or reviews in our controllers here. So right now we're pulling our restaurant information. So we're going to be using our restaurant route on our API. So it's going to be struct URLs, and then we're going to define static let restaurant rest. Spelling is like my downfall. Okay. URL string, and then we're gonna have our base URL path, and then on that we're gonna append restaurants to it. Man, forgot a pair of parentheses. Base. Oh, this is string. Okay. Pack. Okay, cool. And then we can copy paste this and make another one for reviews. Reviews. Did I spell restaurants wrong? Yes. Okay. And yeah. Okay, so today we're going to be using the review URL, but this is going to be the URL that we use to communicate with our backend to pull our data from. Okay. So now that we have a way to kind of like a transportation, like if you think of like our API as like a highway, like connecting our front end to our back end, now we need a way to be able to like send our requests through that highway. So we're going to make a brew and eats model, which is basically going to be where we're going to be defining all of our functions to send those requests over along the URL, which is our highway. So yeah, okay. And this is going to be an observable object because we want to be able to share the state between all of our views and be able to, if we get new restaurant data, be able to update that throughout the rest of our views. And if any of them may be watching this object, that when they see that a change has been made to it, it'll update, like Hannah was mentioning earlier. Yeah. Okay. So I'm going to go back into my folder and create another folder called controllers. And in this, create Bruin Eats model. Okay. And in this, I'm gonna have my imports, import foundation, import SwiftUI. And then I'm gonna define my class, my model class, as an observable object. So any changes to the data that we made will be observable object. Okay, will be able to be viewed. And then I'm gonna make an instance of this called static let shared equals Bruin eats model. And this is just basically this shared means that I'm creating one single instance of this model across my entire app, which will be shared throughout all the views that I'm having later on. Okay. And then I'm going to define another variable, which is going to be my list of restaurants. It's going to be published bar restaurants. Restaurants. Okay. Okay, so this is basically just making a array of type restaurant, which is going to hold each of our individual restaurants in it. Okay. And this published basically means that any changes that we make to this array will automatically be updated to all the other views that we have and update the UI. Okay. Now I'm gonna go back and we want to be able to define our HTTP requests, which are going to communicate using our API to pull the information. So we're going to have a get, post, and delete request. So I'm going to do private enum HTTP method of type string and define my different cases of get, post, delete. Okay. I'm missing. Okay, and now that I have my HTTP request, I'm going to make one general function called make request, which basically is going to be a reusable method, which I use to as kind of like a parent method for my get and post requests, which can call this and basically just format the information I have into JSON when sending it over to the API. So I'm going to define this below here as private function make request. And then method. So whoever's calling this method has to pass in what kind of HTTP method they're using, the URL that they want to send this request to, and then the body of their request if they have any. And then I'm going to add a question mark in case, like if you're making a post request, you're going to have a body to it. But if you're making a get request, you won't have a body. So that's why we're going to make this body field optional. And if the user hasn't inputted anything, it's just going to be null. Okay, And this is gonna return a URL request. Okay. And then inside my function, I'm gonna define my request as a URL request using the URL that the user has passed in. And then request.http method equals method dot raw value, which is basically just processing the string that the user has inputted, either get, post, or delete. This is request. And then request dot set value application JSON. And then specify our content, specify our header field, which is going to be content type, which is the type that we use when you're working with JSON. Okay. And then I'm going to add another if statement for if there is a body to the request, then I want to process it. And if not, I'm just going to return the request as is. So if let body equals to body, basically not null, then I'm going to do request.http body equals to try question mark JSON serialization dot data with JSON object type body, basically just processing in the information that's been inputted. And then I'm going to return my request. Syria. Okay, cool. Okay, then now that I have my overall make request function, I want to specify them into our two different functions that we want to perform, which is to fetch restaurants when we want to print them out, and then also create a function to be able to add the restaurants. So, and as you can see here, basically, both of them are using the make request function that we just defined and passing in, like for the fetch restaurants, passing in get, and then the URL from that constants file, which we just made, which has the URL to our API. And for our get function, that's all we have. But for our add restaurants function, we also have a body, which as we defined earlier was the optional field. And in this one, it's included. Okay. Going back, I'm just going to define these. Maybe for the sake of time, I'm just going to copy paste this code in. But basically, I just go over it once more. We're making our requests in these for the specific function that we want to perform, and then decoding it, and then sending it to and then having it being an async function. So the rest of our app can still keep on going while this request is being processed. And we have this await main actor.run, which basically means that we're going to be waiting for our request to be processed from our base of the project. Yeah. Okay. So I'm just gonna copy paste in these functions for now. Okay. I spelled restaurants wrong. Okay. Not find decoder. Extraneous. Mm, okay. Give me 1 second to see where this error is coming from. I forgot to define the function. So I'm gonna define our decoder function, which is just gonna be used to decode our JSON and the date that we have. So okay, let decoder. Okay. Coder. Okay. Cool. Okay, so now that we have all of our architecture set up for our backend API and we have the methods that we want to be able to send our requests for, we're going to go back into our screens where our restaurant list view is and actually implement and use all the methods that we've created so that we can send these requests to be able to fetch and display all of the restaurants that we want in a list like format like this. Okay. So going back to restaurant list view, we're going to, right now we have restaurant row view, which is like the single object here, but we're gonna use this component in our, sorry, it's a little confusing. This is restaurant row view, and we're gonna use this in restaurant list view to be able to display all of these together. So I'm gonna go back to restaurant row view and create that struct. So maybe for the sake of time, I will copy paste the code in and just walk through it to be able to explain it. Okay. So this is going to be our restaurant list view code. Basically at the top, as Hannah mentioned earlier, we're going to have our environment object here, which is basically connecting our view to the shared Bruin Eats model so that this is kind of the object that we have, but we want to be able to like import it into this screen we have so we can observe all of the changes into the model and then automatically update the UI accordingly. And then we're also going to have one state variable just for this screen, which is going to be our error message. And this is a local state variable, which is only contained to this view. And again, like just having private is always good convention, even though it automatically is. So then looking inside of our view, as we saw before, this is going to be a VStack where we have a bunch of our separate restaurant row views in it. So in our VStack, first on top, we're going to have our title, Bruin Eats, and then we're going to modify it using our modifiers. We're going to specify the font to be a large title and add some padding to the sides for it. Then below that, we're going to have our list, which is going to be of type restaurant. And this is going to basically loop through all the restaurants that we have in our restaurant array and print them out. And then list style is just going to be plain. And then here we have this task do try await to the model. Basically, we're going to try and send this request to fetch restaurants here to be able to use the function that we just made in the Bruin Eats model called fetch restaurants to make that request to get all the restaurants. And in case if it doesn't work, we're going to catch our error message in the state variable that we made here. Yeah. Okay, yeah, just here it says also here, we have our list to display all of our restaurants, and it's going to loop over model.restaurants, which contains all of our restaurants. And then we're going to use .task to perform an async API call to fetch restaurant data from our backend API using our fetch restaurants method. And then if anything goes wrong, just catch our error message. Okay. Cool. And then JSON. See what's wrong with this. Okay, I think I'm missing a pair of parentheses here. Okay, cool. Okay, so now that we have the structure for our screen, we want to be able to actually call it from content view. So as I mentioned before, content view is like kind of our like big main container, which is actually going to be displayed in our preview and going to be displayed as we see here. This is the main function of our project and here it's calling the view content view. So content view is the main one in which we're going to be calling our separate views. And later in the next session, we're going to be doing our navigation and kind of building our structure here for switching between the different screens. So, but for now, we're just going to call our restaurant list view in here. So basically first, we're going to declare a model as a state object. So here we're using a state object because this is the place that we're defining our model in. And this is like our main model that we're using throughout the entire app. And at state object basically just ensures that even if this view is closed, the model will still stay alive and maintain its data. And then inside, we're just going to call our restaurant list view and then have environment object here, which is going to inject our model that we just created into this restaurant list view screen, making it accessible to child views like this. So yeah, okay. For now, I'm just gonna copy paste this information in right now. Okay, wait, I think I'll write this one. So I'm gonna create my state object. then inside the view, I'm gonna have my navigation stack. This is another kind of stack. We're gonna cover it later on next week, but for now I only have one item in it, which is gonna be our restaurant list view. And to restaurant list view, I want to be able to pass in this object of the Brew and Eats model I just made so that it can also observe the changes of this model. Yeah, okay. And then I'm going to do the same in our main function here. I'm going to create the state object. And then pass in the environment object model. Okay. I'm gonna stop running and then rerun. And then hopefully we should see all the restaurants displayed. Okay, cool. So if you're using the code from the demo, I think on GitHub, it's connected to a database which already has all of this information in. So this will all pop up in case you're working on your own project locally with your own database. Whatever you have inserted into your database will pop up here. But yeah, okay. Okay, sorry. I know that was a lot, but are there any questions? Or anything anyone was stuck on about? Okay, sounds good. Cool. Yeah, so right now we kind of just went over like when you log in, how you see this screen. Next week we're going to be covering navigation. So we're going to be going over making our login registration screen and then also being able to click on these to navigate to another page to add your own reviews. And yeah. Cool. Thank you guys for coming today. If you answered a question, you can come up for a prize and we'll continue again next week. And I think we'll have some sort of food again, either boba or something else. And next week will be our last session.